Hello everybody, welcome back. Today you see before you a power supply, not a particularly great power supply. OCZ is not known for making, stupendous power supplies, but really, however, the reason why this is in front of you is because I saw this on Facebook, said it didn't work, $5, and I figured it's $5. I either get it to work and I get a $5 power supply, or I don't give it to work and I've lost $5. Not a big deal. This particular one is a Mod X Stream Pro. Don't know what that means. It looks fairly clean inside. Yeah, let's see if we can get it to work. I've bought a couple of power supplies off of Facebook Marketplace that said that they didn't work, and they just work fine. I didn't have to do anything to them. Will we get that lucky this time? I don't know. Let's find out. So the first thing I do with a power supply that the previous owner says it does not work is I test that theory. Easiest way to do this, plug it in. Don't plug it into anything right off the bat. See if it does anything funny. More than likely it won't do anything funny. So plug it in. Nothing has happened. So the power switch is on. Let's flick that, or actually the power switch is off. Let's flick it on. Still nothing weird. So now we're going to jumper the pins on the 24 pin connector that will trick it into coming on. And the way you do that is you jumper this green pin, come here, the green one to a black one. Doesn't matter which black one, you're just going to ground the green wire. And I don't know what number pin this is, I always forget. But basically it is the pin that is almost directly to the right of your clasp, and it's 1, 2, 3, 4 in from the right. So I've got one of these handy little things. Makes this job easy. You can use a paper clip or pair of tweezers, really anything metal to connect these two. But I got this, I can't remember, in a power supply somewhere, and it works great. You know what, first we're going to shut that off. All right, connect it on. Good connection. So let's flick it on. Hey, you know what? That's a first. I got a power supply that actually doesn't work. So next thing I would do is remove all the plugs that you can remove. Since this one's modular, you can take all these out. Try it again. Still no power. So now we have to crack it open. I'm sure there's other things you can do first, but inside of almost every power supply, you're going to have a fuse, and it could have burned out. So we're going to open it up, and we're going to look for anything obvious that has gone wrong. Now we did just have this plugged in, so I don't want to go poking around into anything. Capacitors could be still charged up. So what we're looking for is obvious signs of something that has burned up. A capacitor that has swelled up and popped, or really anything that's just a miss. Okay. I want to disconnect this, so I'm going to cut the zip tie and disconnect the fan right here. A little bit of glue on it, trying to thwart my efforts. There we go. Now, since we just made a change, we disconnected the fan. The next thing we want to check for is the presence of a fuse. And this guy will come in handy here for this. And the fuse is right. Oh, my left hand is not steady enough for that. Fuse is a cylindrical fuse right there. Can you see it? That's our fuse. So we'll test and see if that's good. And so checking the fuse is going to be simple. We got our high quality multimeter here. It does do good continuity. So all we're going to do is reach in and touch at the base and then touch at the top. And we'll see if it has continuity. That seems like it's blown. So this fuse is labeled down inside there. 10 amps, 250 volts. We want to get a fuse that is of the same type to replace that with. Hopefully this is just the fuse. That would be kind of nice, actually. Unless, of course, there's an underlying issue that caused the fuse to go out. Then we'd have to find that. So before we start ripping this board out of here, the next thing I want to check and see, if we have a short on main. And basically we're just going to see if there's connectivity between our two power mains, and no, we don't. So it is very possible that we just have a bad fuse. So in order to get this fuse out of here, there are a few screws, right here, 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 here. Sometimes they'll bury one in the middle somewhere. It doesn't look like there is. You would see one of these somewhere there, in the middle. So it should be simple to take apart. This is going to have to wait until tomorrow because I have to go buy some fuses. And you can get these at like Home Depot and stuff. They carry various fuses that go into appliances and whatnot, and they should have these. So we'll find out tomorrow. You know what? Let's take it apart now. Why not? So since we don't even have power going into the power supply, well, I can't say probably. I'm not an electrical engineer or anything like that. I just kind of play one on TV. I'm still going to be careful, but none of this should be powered up. It doesn't have the ability to get power into the system. Into the circuit, not into the system. 220, 221, whatever it takes, If I unclip that, I might have more room. I don't want to unhook the switches from, when I say switches, your on and off, and your main here. I don't want to have to undo those. So if there's enough room to just pull this board out of here as is, that would be great. There we go. And yeah, there's a good amount of room there. I could probably work around this thing. Alright, so here's our view of our fuse in a little bit better detail. So I'm going to fire up the old soldering station. Get this thing apart. Well, looking on the back of the board here, these are the two connections I want to undo. This is one of our mains. So main power goes into the fuse here, up into the fuse and comes back down around, and then off to wherever it is it goes. So I am going to remove, like I said, this one and this one. Okay, solder sucker's good and warmed up. This thing is, sometimes it works amazing and sometimes it works terrible. So let's see what happens. There we go, that worked. Most of it that time. I think I got most of it. Come on, buddy. You guys can't even see it. Darn thing. Well, the bottom part is it's pretty loose. There we go. So here it is removed. It doesn't look blown, but these, I think they're called ceramic fuses. A lot of times this won't look any different. There's a wire on the inside here that kind of explodes, and it doesn't have to do it in such a way that it makes it makes an indication on the outside of the packaging. Okay, it's the next day, and I set off a Rube Goldberg machine of human suffering yesterday, and I got some of these in the mail. Well, delivered. And we have... Why is this in a static-proof bag? That seems like overkill. Anyway, wow, okay. Came in a fancy little package with a fancy little plastic carrying case, and look at that. All right, we're set for probably the rest of my life because this doesn't happen often. So we're gonna stick this in there, and it is the same size. Basically, you know, same ratings, 250 watts, 10 amps. Let's stick it in there. Come on, buddy. There we go. All right, I got the fan in there just holding the, up. Let me turn on the old solder station. So I've said this multiple times, I am not good at soldering, but you'll get to watch me do this and screw it up in real time. I should do it. Thank you, solder station. So, oh, that's actually kind of. Man, I grab my nips. All right, cool. So now we're gonna put this thing back together. Not all the way. We're gonna plug it in and see if it works, but okay, so let's put this thing back together. Oh, wait, what's here? Did you guys see where that went? Where'd it go? There's only so many places it can go. There we go. So, I'll flip it off. Switch it off. We're not going to flip it off. We're going to take that out. And we are going to plug it in. Oh, you're not going to be... All right. That's fine. Okay, so I'm gonna flip this thing on, and nothing should happen. I'm gonna flip this thing on, and nothing should happen, and nothing should happen, and nothing should happen. Ooh. It wasn't the fuse. Alright, well that was certainly enjoyable. Poked around a little bit. The fuse did not blow. My circuit breaker tripped. We don't have an open short at the mains. I mean, it could be further back, I suppose. So, I'm going to do some poking around. Nothing looks burnt. Nothing, you know, there was no smoke. It's very odd. I'm going to do some poking around, see what I can find. Alright, well, so I've got some bad news. Not so much for you, but for me. Kind of out my $5. Because this thing's a little farther gone than I care to try and put into a $5 power supply. I'm finding a lot of the diodes are bad on it. I've marked a few of them. This here is a diode that works correctly. And I understand that testing them in the board isn't always a good idea. But, I mean, I think it's kind of a proof of concept here. So one way, we get 458. And the other way, you know, 0.458 of a volt. And the other way, we get nothing because it's working correctly as a one-way switch. The diodes are designed in a way that power can flow through one way, but not the other. So this one is good. And then I have another diode over here. Right here, this is a larger one. And pretty sure it's these two. We got 0.38 volts going one way. And we got 1.5 volts going the other way. So it has a voltage drop over it, kind of a large voltage drop. And I don't know enough about this to tell you that that's good or bad. So 15 down to 8 or 3. So that's like 1.2 volts drop, which is kind of large. In my understanding, it should be like half a volt to maybe like 0.8 volts. Let's see here. So then we got this one here. .35, 0.326. So that's an entire volt drop. And then we got, where's my other one? This one right here. 0.53 volts going through it. Switch it up. 0.5, almost 3 volts going through it. So that one's allowing power to go through both ways. So, I mean, this could be our only bad one. You know, the range on these ones where it's dropping like almost a volt. It does have resistance going through one way and seemingly no resistance through the other way, which is the way it should work. But this one here, which I'm fairly positive is, you know, no bueno. It's located deep down inside. Can I get some light? It's a difficult one to see. Where's my flashlight? Man, is this difficult? See, I can't even get you in there to see it. That's how tucked way down in there it is. What are the numbers? R105. See it right down there, R105? I'm not taking all this stuff out around it to get to it. It's kind of a bummer that I can't just like, maybe I could desolder it from the bottom and put a diode on the bottom? Maybe? I don't know. That's beyond the scope of this video today. So, this is the first can we fix it that we couldn't fix it. That's was bound to happen. So it finally happened. But I mean, for $5, I got a couple of modular power supply cables. So that's not bad. That's not bad at all. So anyways, what did we do? We tore it apart. We tested our fuse. Fuse was blown. We replaced the fuse, plugged it in, blew the circuit breaker, started poking around, found some bad diodes. And that's not to say that, like, say I did dig through this and I replaced those diodes. There could be anything else on this board that has gone bad. So, like I said, this isn't a cause this isn't a worthy cause to tear apart, replace a tiny little 10-cent diode, throw it back together. So, anyways, that was what is all over this. Gross. So anyways, that was a kind of a learning experience. First one that we couldn't fix. Not that we couldn't, but really I don't want to put the time and effort into it. And that's going to be that. Thank you very much for watching. I hope you learned something. I learned a little bit, and I hope to see you in the next one. Thank you very much for watching.